In this video, we will learn about a real loci and complex loci. So, basically, the word locus is from this word comes from location, right? So, a locus of points can be described by an equation. If you are asked to find a locus of points for certain rule, you need to give an equation that is always satisfied by that rule, right? So the location of all points can be described by an equation. This is the location of all points can be described by an equation, and if you are asked to find a locus of that points for a certain rule, you need to give an equation that is always satisfied by that rule. For example, we will consider the example of a circle. Let P be the set of points xy of this form xy, and these points are 5 units away from the origin. So how can you find the locus of that point? Let P be the set of that points xy, and they have given us the condition. I have already in the definition I said that you need to give an equation that is always satisfied by that rule. No, here the condition is given that all type of points, they are equidistant or they are 5 units away from the origin. So when you will take all the points which are 5 units away from the center or from the origin, then you will get a shape, whatever the shape you will get when you will join them. Then you will see that if this condition is that all the points are same distance away from the origin or from the center, you will get a shape like that. If they are 5 units away, this point is 5 units away, this point is this point, all the points are 5 units away from this center, and when you will join all these points, you will get a circular shape, right? And this is the locus, this is the locus of location of those points, right? So we will get a circle, and this is called the locus or loci, and they all the points, they are equidistant or 5 units away from the center, right? So how can we solve this question? We will see that the set of all points a fixed distance from a single point is called circle. So the locus of points is the equation of circle with center at 0 0, and the radius, you know, it is given 5 units away. So what we will do, x is over first part, y is over second part. So x minus 0 whole square plus y minus 0 whole square, it is equidistance 5 unit. So 5 whole square, it is radius. This will be radius of circle, which is 5 units away. So we will get equation x square plus y square is equal to 25. So this is the locus of this equation, and this will satisfy that all the points are 5 units away from the center. Now this is the definition of a real loci or locus, and always remember that real loci, it is plotted on Cartesian plane. But if they ask you about complex loci, so keep in mind that complex loci, this is plotted on Argand diagram. As we have discussed, Argand diagram is similar to Cartesian plane, but in Argand diagram we will draw imaginary numbers along y-axis and the real number along x-axis. The rules are equal, same, but for the imaginary numbers, as we have to deal with the imaginary number in complex numbers, so we will draw them on Argand diagram. Now In this question, they will ask you a complex number z is represented by the points P in the Argand diagram. Z satisfies this equation. Sketch the locus of the point. So, how can we sketch this locus of those points in the Argand diagram? They have given this condition that z minus 3 plus 4 iota modulus is equal to 4. Now we know that what is the value of z in a complex number. Z is equal to x plus iota y. We always take it in complex numbers. It is denoted by z. So when we will apply Pythagoras theorem, then you know z mod is equal to x square plus y square. This is by Pythagoras theorem. Now taking the square on both sides, what will be happen? Z mod square will give you x square plus y square, because when you will take the square on this side, this square and under root will cancel each other and you have got x square plus y square. Now by using this definition, we will put the value of z and then we will get the z modulus square. Now we will take this equation, I have written it here, and when we will, according to this rule, we will take the square on both sides, right? When we are taking the square on both sides, then in the next step you will put the value of z, which is x plus iota y here. I put it here. Then you will make the pairs of real parts. X minus 3 is real part, and with iota, this is the imaginary part. You will take iota as common, form iy and 4i. So it will become your imaginary part and it will become your real part. And here it is equal to 16. So you will get the equation of a circle. As you know about the equation of circle, x minus 0 whole square is equal to y minus 0 whole square. So in this case, we will get this equation. And this equation shows that the center of the circle is, if here is a minus, then it means, according to formula, x minus x plus minus 3, right, whole square, sorry, plus y plus 4 whole square is equal to 16, right? Or 16 will become your whole square of 4. So x plus 0 plus y plus 0, it will give you equation of the circle. In this case, we have minus 3 and we have plus 4. So the center of the circle will be, this will be x minus 3 whole square x minus 0, it will become plus 3 here because we have x minus 3, right? And we have y plus 4 here, so it will become y minus 4 whole square. So the center of the circle will become positive 3 and negative 4, because the equation of the circle x minus 3 and y minus 0. So in this case, we will convert it into this form, x minus 0, this will be 0, and automatically it is x minus 3. So here we will write plus 3 whole square, and here we have y plus 4, but we have the formula y minus 0 something, so this will convert into y minus 4 whole square. So they will show us the center of the circle, which will be 3 and minus 4. and the radius of the circle will be 4. The whole square of r will be radius of the circle. Now how can we draw it on the arc diagram? In arc diagram, you know that the vertical axis is our imaginary axis, and we have a real axis as along x-axis. So the center is at 3 4. So I, from this origin, I will move 3 steps here, 1 2 3, and minus 4. So I will move down the line, which will be 1 2 3 minus 4. So this will be the center of the circle, which is 3 minus 4, right? And then they have shown that the radius of the circle is 4 unit away. So 4 unit will be 1 2 3 4. So our circle will be like, if you will draw it, so it will be like that. You will draw it properly with, I have drawn it randomly. So this is the locus of this, which is they have asked in our question, and in this way we will sketch the locus of the given point, and you will show here 3 minus 4, and you will show here that this radius is 4 unit away here, and from here also 4 unit away. So always remember where the locus will be of the circle will be. You have to know where will be the center, 3 minus 4. So it will be in our fourth quadrant, where x-axis is positive and y-axis is negative here. So in this way we will draw the complex loci.